Hello again, folks, and welcome to the next video in the series on rational expressions. So a couple days ago, I posted a video on multiplying and dividing rational expressions. I'll put a link to that video at the end of this one. But today we're going to go into adding and subtracting. Just like before, you should have some paper and a pencil or a pen to kind of follow along. I'm going to ask you to pause the video a couple times to do a couple problems on your own while we're still going through this. So if you need to get that ready, please take the time to do that right now. So again, we're going to do adding, subtracting. We do it, it seems like it's out of order, even though it's really not, because especially when we get to the dividing part, or the subtracting part, I should say, we actually need the multiplying bit to go with that. So make sure you know how to multiply rational expressions before you go into adding, subtracting. But before we get into the whole meat and potatoes of this, let's go back to elementary school for a second and just do a quick review of how do we add, subtract fractions in general. So ask yourself real quick, what do we always have to have if we're going to add or subtract two fractions? Well, we have to have a common denominator. And you can see on this first example here, my denominator is already the same, so there's nothing else I got to do. When we add the fractions, we just combine the numerators. So we do 5 plus 2 is 7, and then the denominator stays the same, so you enter the sum over 3, and you're done. You go on with that. But what if they're not the same? So what if we have like 1/4 plus 3/5? How do we get that common denominator? Well, you're probably saying to yourself already, because you know your basics from a few years ago. We have to multiply by the kind of surefire way to do it. We can multiply by the opposite denominator, right? So we can multiply that first fraction by 5 over 5, and then the second fraction by 4 over 4. Some of the teachers might have called that multiplying by a fancy 1, because 5 over 5 and 4 over 4 is a small way to write 1. So we're not changing the quantities, we're just changing how they look. And then when we combine those fractions together, that first one becomes 5 over 20, multiply straight across, and the second one becomes 12 over 20. And now that we have the common denominator, we can just add across on top, so 17 over 20, and again, that's your final answer. Now, of course, if that answer could have been simplified, you should do that, but in this case, that's all we can do with that, okay? So I'm going to give you one more. Just go and pause the video real quick, even though we're not into the main part of the rational expressions part. Just go and pause the video real fast and do that quick little subtraction. Then we'll go over the answer in about 5 seconds here. So again, for our common denominator, we're going to multiply by the opposite denominator. So we're going to multiply that first one by 7 over 7. The second one by 3 over 3 gives us 21 on the bottom. Multiplying on top, we have 56, and then 30. But notice it is subtracting this time. So again, my final answer, keeping the denominator the same, final answer would be 26 over 20. Okay? Now, as we move forward, once we get into these rational expressions, the process stays exactly the same. There's no difference. We still need a common denominator, right? So let's go and try the first one here. So we have 1 over x plus 3 plus 1 over x minus 5. So what do you think? So how are we going to get that common denominator? What do you think we're going to multiply both those fractions by? Well, we're still going to do the same process, right? So we're going to multiply each fraction by the opposite denominator. So I kind of color coded these again, just so you can kind of see what the process is. But we're going to multiply this first fraction, the 1 over x plus 3 times x minus 5 over itself. So that fancy 1, kind of what we call it sometimes. And then the 1 over x minus 5, multiply that by the x plus 3 over itself. And then we just combine those guys up top. So we have x minus 5 times 1, which is x minus 5, x plus 3 times 1, which is x plus 3. You can combine those like terms because I got x plus x, so that becomes 2x. And then negative 5 plus 3 which is -2. Okay, and again, the bottom stays the same. So I'm okay with that being the final answer. You can talk to your teacher. They may want you to multiply that denominator out. I think either way is mathematically equivalent. So if you write it like that, I think it's okay. You could do this also. You can FOIL or box method that bottom out. You get x squared minus 2x minus 15. But again, they're both mathematically equivalent. So I think either one would be okay. Okay. And that's the whole process. There's really no difference whether you're adding or subtracting. Now, the one we're going to do next is going to be a subtracting question. The main thing, you have to watch the signs. Okay, so here's one more. Even though we've only done one, I'm going to go and ask you to pause the video here and see if you can do this one by yourself. Again, watch the signs. We're subtracting these instead of adding. And there's also some coefficients up top, which you're going to have to deal with. So go and pause the video, give you a few seconds, and then we'll get back together and go through the solution. Okay, so again, same exact process. So multiply that first fraction by the opposite denominator, x minus 6. Multiply the second fraction by the x minus 1 over itself. But again, we have to distribute. Okay, so we have the 5 times x minus 6, and then the 4 times x minus 1. And of course, the bottom's going to be the same. This is going to be the x minus 6 times x minus 1. Now, the only thing you got to watch out for here when you do the distributing, we have that minus sign, right? So the first fraction, nothing crazy, 5x minus 30, that's fine. And then the second one is 4x minus 4 when you distribute the 4 to there. But when you combine the terms, okay, this last step to kind of get it cleaned up, we got 5x minus 4x, so that's just 1x or x, and then -30 plus 4, which would be -26, okay? Don't forget back in the last unit when we were doing the polynomials, adding, subtracting polynomials, watch those signs, okay? So that last box there would be your final answer. And again, you can multiply that bottom out. I'm not going to in this case. I think that's going to be okay with everybody. Okay. And that's it. You know, whether you're adding, subtracting, it's the exact same process. Just got to watch signs, watch your distributing, and make sure you're kind of keeping everything straight. Okay. So I'm going to put 2 more problems up here. I'm going to put them both at the same time. And again, pause the video, give yourself a few minutes, give yourself some space on a paper, work both of them out, and then I'm going to run through the solutions fairly quickly, and then I'll wrap some things up and tell you how to kind of move forward to the next one. Okay, for the first one on the left, so that's an adding question, but again, process stays the same. I did condense the steps in this case, okay, but remember, I'm still multiplying by the opposite one, so my bottom one is going to be x plus 6 times 3x plus 1. And then the top, I take that x plus 6 multiplied by 2, x times 3x plus 1, distribute the 2, distribute the x up on top, and then combine like terms. So your final answer is going to be right here, the 3x squared plus 3x plus 12 over x plus 6 and 3x plus 1. And that's it. Okay, and I'll give you a second to kind of check through. If you didn't quite get that answer when you worked it out yourself, you can pause the video and go back and double check some of your numbers. The one on the right, so this is a subtraction, but the process stays the same. And again, I kind of condensed the steps a little bit. We got 3x times x plus 3, 2x times x minus 8. The bottom is just the combination of the two. Distribute and combine like terms. So we got 3x squared plus 9x, and then negative 2x squared plus 16x. Again, watching that negative sign. Combine those terms together, and we have x squared plus 27x. And that's pretty much it. You know, the denominators can get a little bit more complicated. You know, they can have more than 2 terms, or like a quadratic term, or what have you. But the process really just doesn't change. Always remember you have to have that common denominator. Okay. So again, just like before, look for some practice problems on Classroom to complete and turn in to me for some feedback. If you haven't done the multiplying and dividing assignment, please make sure and do that as well and get that turned in as soon as possible. If you have any questions, email me or email your teacher if you don't have me as your classroom teacher, or you can log into my Google Meet, and that link is posted on Classroom also. Okay. Feel free to like this, share it with anybody that maybe doesn't have me or is having some trouble adding, subtracting. Hope this was helpful. If you want to subscribe to this channel, please feel free to do that also. I am posting some pre-calculus videos also, like we're doing some of the trig functions and stuff like that. So just be mindful that I'll have some other content up here as well. Again, hope you found this helpful and productive. Best of luck to you as we kind of adjust to this new reality. Keep studying.